Welcome back. We're going to continue on with the 2018 AP Calculus exam. We're going to We're going to start with work on question 5. Now, question 5 was a polar function. Now, polar function is not on the 2020, but the math behind it is really good for us. So they give us two graphs here. They give us first a circle right here. So they give us a circle, and you can kind of see that that's the outline right here. And then they give us this lemicon, which is this little butt-shaped graph right there. All right, and they tell us where the curves meet. Now, the first question says let R be the shaded region inside the circle and outside the lemicon. Now, if you notice, they gave us a little region right here. And if we draw like a little rectangle right here, and they're asking us to find the area of this. So it's really quick and simple. If we look at the rectangle of mathematics right here, right, we got this little piece. I'm looking for only the shaded region right here. Remember, all this was dashed right down there. We want to look for the shaded region. Well, how do we get the shaded region? Well, we're going to take the area of the outside minus the area of the inside. Well, what's on the outside? Well, the outside is the area of our circle, and the inside is our lemicon. So we're just going to subtract those two areas. So let's review. Well, how do you find the area of a polar? Well, that was just 1/2 from A to B r squared d theta. Now we do have a choice. We can write this as two integrals, or we can write this as one, because they basically share the same region. Everything's the same. So I'm going to write this as a single integral, and you would get area is 1/2. The integral goes from, they tell us, pi over 3 to 5 pi over 3. The area of the outside is our circle, so we're going to take 2, but don't forget you got to square it. Don't forget to square it, minus the lemicon, which is just 3 plus 2 cosine theta squared d theta. And there's your answer. Now let's point this out. Ready? The integral and the 1/2, and all that's plus 1. Basically, everything else is plus 2. Should be an easy 3 points for you on the AP right there. All right, so let's take a look at part B. Part B says find the slope of the tangent line. Oh no, to the graph of the lemicon at pi over 2. Now, if we look careful, we're looking for the slope. Slope is dy over dx. So we have to convert. Our polar to rectangular, and that's not too hard to do. Well, what is y equal to? Y is equal to r sine theta, and x is equal to r cosine theta. And now we can take the derivative. Well, how do we take the derivative of r sine theta? That, of course, is our product rule. So let's see here. We're going to get r, which is this r times, whoops, that's a weird looking r times the derivative second, which is cosine theta, plus the second sine of theta times r prime, divided by, ready, let's take a look here. On the bottom, same thing, product rule, r times negative sine theta, that's the derivative cosine, plus the second cosine theta times r prime. And we know what r is, so let's see what r prime is going to be. What's r prime going to be? Negative 2 sine of theta. And there we go. And now I'm going to rewrite this all out. It's going to be really long and nasty. R, which was 3 plus 2 cosine theta, times cosine theta, plus sine theta times negative 2 sine theta. And on the bottom, negative 3 plus 2 cosine theta times sine theta plus cosine theta times negative 2 sine of theta. You're going to get 2 points for that derivative right there. It's nasty. It's ugly. It's a lot of points. Don't get it wrong. All right, so now we're ready to finally get that derivative, right, that we've always wanted. Now we're going to plug in pi over 2. All right. Okay. This is ugly, but that's not too bad. Oh, we're lucky. What's cosine of pi over 2? 0. So it's our first term there, just 0. Don't even have to worry about it. Sine of pi over 2 is 1 times, ready? Oh, that becomes sine of pi over 2 times negative 2, which is negative 2. Nice. Let's look here. Here we get a negative. This becomes 3 plus 0 times 1 plus, and again, cosine of pi over 2 is 0. The whole term is 0. And what do you wind up with? 2/3. Although if you leave right there, that's okay too. 1 point. That's 6 points. That's not too hard. That's 6 points, and you're well above the national average already. All right, part C. Oh no, now we have a particle moving. We love it when particles move, right? A particle is moving along the portion of the curve r equals 3 plus 2 cosine theta. So it's moving along that lemma sign right there for us, okay? The particle moves in such a way that the distance between the particle and the origin increases at a constant rate of 3 units per second. Oh my gosh, you know what this sounds like again to me? That's right, this sounds like to me another related rate problem. So we want to find the rate at which the angle is changing. So this is a related rate right here. So let's see what we're given here. We are given that the distance between the particles is increasing. So they're telling us dr dt is 3, like the units per second. Okay, now find the rate at which the angle is changing. So they're asking us to find d theta dt when theta equals pi over 3. So let's see here. This is just our derivative. All right, so r, which is 3 plus 2 cosine of theta, dr dt is just going to become negative 2 sine theta d theta dt. We love related rates, don't we? Oh my gosh, there's another one. And then we just plug in everything. What is dr dt going to equal? So we're looking for d theta dt. d theta dr dt is 3 equals negative 2. Sine of pi over 3, who knows what that is? Whatever that is, sine of pi over 3 is, what's that, root 3 over 2 times d theta dt. Here, those cancel. And what you're left with is d theta dt equals negative 3 over root 3. And you can leave it like this, or you can just write that as negative root 3. Radians, theta is measured in radians per second. Let's take a look here. You get 1 point for the derivative, and basically 2 points for your answer. 1 point for plugging in and 1 point for your answer there. That's not a hard question right there to get. Get these right. And I'll see you guys on question number 6.